Hi everybody, I'm going to be doing a few of the lesson 11 practice problems. Number 1, it said, what are the points of intersection between the graphs of the functions? And so for this, we're going to use Desmos. For some, we're using factoring. For this, we're just getting the idea. So I'm going to go to Desmos. I'm going to type this in, which that's a third degree, 1, 2, 3, running into a first degree, which is a line. So it might have multiple intersections. Let's go look. Whoopsie. So let's look here. We've got x squared times, x plus 1. And I want to know, when does that run into x plus 1? And I could zoom in a little bit here. Looks like 2 points. They intersect at the point 1, 2 and negative 1, 0. Those are the only 2 points that satisfy both of those equations. If I plugged a 1 in for x, it would spit out a 2. If I put a 1 in right here, it spits out a 2. If I put a negative 1 into this function, it will spit out 0 for the output. I'll put a negative 1 in there. Okay. So I could kind of show myself what that looked like too. One, 2, and negative 1, 0. Number 2, select all the points of intersection between the graphs of these two. Now this one, you needed to show the algebra. And right now, both sides are in factored form. So when will this run into this? So first thing we're going to do is multiply. I'll come over here. I'll do a box. Hopefully some of you are getting to the point where you might not need the box to multiply. So this is x squared, 5x, negative 2x, negative 10. So this side is x squared plus 3x minus 10. And when does that run into? Now this one I'll show you how you can do it without the box. 2x squared, negative 4x plus 1x makes negative 3x minus 2. You could also do a box. All right, now the only way to solve a quadratic that has x squared and x is to get everything on one side and try to factor it. So I would move all these over here because I don't want to make the x squareds negative. So I'm going to subtract that, add that. Whatever I do to one side, I have to do to the other. So now nothing over here. And I've got x squared minus 6x plus 8. What numbers will make this equation equal to 0? Well, if I factor it, I'll be able to tell. So I'm going to use my little Timba puzzle. What two numbers multiply to 8 but add to negative 6? Sorry, guys. Negative 2 and negative 4. So that means x minus 4 times x minus 2. And I like factored form because now I can tell that whatever makes this 0 is one of the solutions. So the solutions are 4 and 2. Remember what we're doing here. We're trying to find where there's two quadratics. I don't really know what they look like, but it looks like they must run into each other twice because I got two x coordinates. So they run into each other at 4 something and 2 something. Now I know these are multiple choice, but how do they get the second part? You're going to take that x value and you're going to plug it into either one because this point satisfies both equations. So be smart and choose the easiest one. I think this one looks the easiest. If I put a 4 in there, 4 plus 5 is 9 times, if I put a 4 in there, 4 minus 2 is 2. 9 times 2, that's how you get the 18. Now put a 2 in. 2 plus 5 is 7 times 2 minus 2 is 0. 7 times 0, 0. All right, number 3. what are the solutions of this equation? So now we've got, right, if you're visualizing it, that's a even running into a constant down here at negative 15. So probably two solutions. So I'm going to multiply this. You could use a box or you could do it in your head, whatever you can do at this point. Now to solve this, I got to get everything on one side. So I'm going to bring this over here. So I've got x squared plus 2x equals. Now you can leave the 0 off, or it might help if you want to use your Timba puzzle to actually write it in. What numbers would turn that equation into 0? Well, let's do our puzzle. What two numbers multiply to 0 but add to 2? 0. Sorry, I don't know if that was too dark in here. And 2. So this is x plus 0, x plus 2. Well, what will make this guy 0? 0. So one of my answers is 0. And then what will turn this into a 0? Negative 2. Now this one, you might hopefully recognize that you already know what the output is, right? Because if you plugged it in, this equation, no matter what, is always negative 15. So I already know those are the answers. If that is confusing to you, you could take 0, you could plug it in here. 0 minus 3 is negative 3 times 0 plus 5 is 5. Negative 3 times 5, negative 15. If you put a negative 2 in, negative 2 minus 3 is negative 5 times negative 2 plus 5 is 3. You'll see you still get negative 15. Nothing wrong with going to Desmos and checking, but that's where those two functions intersect. And I can't remember, did we do anything else? I think I just assigned 1, 2, and 3. That's it. Well, I hope that helped, and I'll see you soon. Bye.